Hi everyone, since I couldn't be there with you today because I'm at the dentist, I thought I'd make a video for you so that if you are struggling to understand density based on the notes, that we can go through it together and you can still kind of listen to me talk to you. So in the notes, you should have written down that the formula for density is equal to mass over volume, otherwise known as D equals M over V. Okay, this is our formula, and our units are always going to be grams per milliliter or grams per centimeter cubed. The difference is whether or not you have milliliters or centimeters cubed at the bottom. And we're going to use a method called the guess method to help us show all of our work. Okay, so the guess method stands for given, unknown, equation, substitute, and solve. So these are the steps that I'm going to walk you through. Now, one thing to keep in mind is in this lesson, we've learned 3 equations or formulas that are possible. The first one and most important one being our density formula. Okay, density equals mass over volume. The second equation that we learned was the volume of a cube or rectangular prism, which is length times width times height. And when you do this, your units for volume end up being centimeters cubed because you used a ruler to measure length times width times height. The third equation that we learned was if you don't have a rectangular prism or a cube, you can use water displacement to find the volume of your object, and that's your final volume minus your initial volume. And that involves a graduated cylinder, which you saw in this picture here. Okay, so we kind of have formula 1 for volume, formula 2 for volume, depending on what you have, and then we have our density formula. So those are the 3 equations that we're really going to want to be thinking about to see if we need any of them. So when we look at example number 1, it says, what is the density of an object that has a mass of 34.5 grams if it was added to a graduated cylinder filled with 30 milliliters of water and the water rose to 66.8 milliliters? So the thing I want you to focus on is your units, the word that comes right after the number. That's going to be what really helps you decide what it is. So for example, because I see grams, I know that this is mass. So I'm going to write down my givens or the things that are in the problem. Remember, we're going to follow the guess method. So I know that my mass is 34.5 grams. Now, because I see milliliters here, I know that there are 2 volumes. I have the first volume is 30 milliliters, and the second volume is 66.8 milliliters. But we need to be able to distinguish between them. Now, they describe a graduated cylinder filled with water. So that tells us that they did water displacement in their lab. Okay, or their experiment. They did water displacement. So we see that the initial amount with water was 30, so we would put an I for initial. And then after they added the object to the cylinder, it went up. So we add, that would be our final volume. So now that we have our givens, we write down our unknowns. So what are we looking for? When you're trying to find your unknown, one of the key things you want to look at is this keyword here. It says, what is? And it says, what is the density? So that tells us that density is our unknown. It's the big question. Okay, so then we write down, okay, what equations might I need for this problem? Okay, we see that we know we're going to need our density equals mass over volume equation. And we also know that we're going to need our volume is equal to V final minus V initial formula because we had initial and final volumes and they were describing water displacement. So now that we know our formulas, we can substitute and solve. So now that we know this, we're just going to kind of solve it over here. Okay, so the first one we're going to want to find is volume. So our volume is our final, which is 66.8 milliliters, minus 30 milliliters. Now, I like to write things, numbers that have units in parentheses. That way nothing, like I remember that those units stay together. So now when I subtract, remember when you subtract, your units combine. So milliliters and milliliters mean that my unit will remain milliliters. And then 66.8 minus 30 is going to give us 36.8 milliliters. And that's the volume of our object. Now that we have the volume of our object, we can plug it in to our density formula. So we know that density is equal to mass, which was 34.5 grams, divided by our volume, 36.8 milliliters. Now, because we're dividing, we can't just keep our units are going to combine. And since they don't cancel out, like the grams and the milliliters are going to stay together, that means when we divide, we're going to keep them the way they are. Nothing canceled out. And a key thing to remember is that when you put this in the calculator, this number here, the top number goes in first in your calculator. So it should be 34.5 divided by 36.8, not the other way around. And when we do this, we get your calculator is going to give you 0.9375. And a good rule of thumb is we can just round to two numbers after the decimal place. And so the 7 will make the 3 round up. So our final answer is going to be 0.94 grams per milliliter. So this one was fairly straightforward, involving water displacement. One note about our units, in case you don't know this from your math class, because I know some of you think that math is the enemy, but it is not. If you are given the guide or the rules. So one thing to know is that when you are adding or subtracting, okay, the units have to be the same. Okay. And they don't like combine or anything like that. But when you are multiplying or dividing, the units are going to combine. Okay, so for example, what this would look like is if I have 10 milliliters plus 5 milliliters, since they have the same unit, that means I'm allowed to add them together, and they don't combine. It's just going to be 15.0 milliliters. However, same thing if I were to subtract. But if we were to multiply something, so for example, let's say we have something that's 5 grams, and I'm multiplying it by 10 grams per centimeter. No, sorry, let's do 5 centimeters cubed times 10 grams per centimeter cubed. Well, because we have grams or centimeters cubed here, which is in the numerator, and centimeters cubed there, they are going to end up canceling each other out. So this would be 50 grams. The centimeters cubed disappears. Or, for example, if we have 4 centimeters times 4 centimeters, that would give us 16 centimeters squared. because since I have 2 centimeters and nothing cancels out, like we don't have one on the top and the bottom, they combine. So that's just a little mini lesson on units in case you find that helpful. Example number 2 is going to be very similar, but they're giving us slightly different information. So if we look at what we are given in this problem, we see that we've got 0.98 grams per centimeter cubed. We have 4 centimeters, 3 centimeters, and 2 centimeters in the problem. So because this has grams and centimeters, and it says it's the density of this, both of those things match. So I know I can say that my density is 0.98 grams per centimeter cubed. We see that we're given our measurements. So this means our length, our width, and our height are all given to us here, the dimensions of this piece of wood. Our unknown, the thing that they want to know that's missing, is it says, what is the mass? So that means M for mass is our big missing variable. And the equations that we are looking for, well, because we see length and width and height, we know that we're going to use our length times width times height formula to solve for volume. And because they've given us density, we're going to need to use our density equals mass over volume formula to solve for mass using that particular formula. So now we can go ahead and solve. So the first thing we want to do is solve for volume. So our volume is going to be 4 centimeters times 3 centimeters times 2 centimeters. And this is where our mini lesson on units comes into hand, because since I know that I'm multiplying and my units are the same, they are going to combine, and it gives us 24 centimeters cubed. And then now that we know our volume, we can plug it in to our density problem, our density formula. So our density is equal to mass over volume, and we're going to want to rearrange this formula. So here, since density is equal to mass over volume, but mass is what I'm looking for, you can do it one of two ways. We can say, okay, I need to do the opposite to move the volume to the other side. That's the goal of what we want to do. So we can do the opposite by multiplying by volume on both sides. That means volume will cancel out on the right side, and mass is equal to volume times density. Okay, now that I know that mass is equal to volume times density, all I have to do is plug in my volume and density. I know that my volume is 24 centimeters cubed, and I'm multiplying it by my density, which is 0.98 grams per centimeter cubed. We see that centimeters cubed is going to cancel out with centimeters cubed when they combine. And so my mass is going to be 23.52, and grams is the only unit that didn't cancel out. And there we have it. So hopefully this is helping you guys. And if we look at example number 3, we're going to follow the guess method again. So let's write down what is given to us, okay? The first numbers we see are 1.57 grams per milliliter and 8.7 grams. When I see something that has both units, that means I've got density. Grams always means mass. So I'm just going to record that over here on my paper. So density equals 1.57 grams per milliliter. And remember, your units for density can change. It could be grams per milliliter or centimeters cubed, depending on what you have in the problem. And our mass is 8.7 grams. So we only have 2 givens, which is nice, makes it nice and simple. We have our unknown. Well, it says, what is the volume? So we are missing our volume here. And the only equation that we need based on what we have is going to be our density formula. We know density is equal to mass over volume. The problem is we know that this equation is going to be solving for density and we need mass. So what we're going to do is rearrange that formula. So if we know that density is equal to mass over volume, and what we want to find is volume, the first thing we have to realize is that it's at the bottom of a fraction. So we need to get rid of that fraction by putting density over 1 and cross multiplying. So if we multiply 1 times m, that gives us m, and volume times density for the other side. Well, hey, that's our mass formula, which is great. But we still need to find volume, and it's not alone yet. So if we notice, it's being multiplied by density, so we do the opposite of the math. And since density is what we want to move, that is the thing that we're going to divide. So we divide by density, and that shows us that volume is equal to mass divided by density. So one of the reasons why your algebra teachers were teaching you algebra is because you were going to need it in chemistry class. Okay, so now that we know that volume is equal to mass divided by density, we can plug in our numbers. 8.7 grams for our volume divided by 1.57 grams per milliliter. We see that we have grams in the top and the bottom here. So that's going to cancel out. That's going to give us just milliliters, which is good because volume is accurately measured using the unit of milliliters. And so 8.7 divided by 1.57 is going to give us 5.54 when rounded to 2 numbers after the decimal milliliters. So hopefully you find this video helpful for you. Remember that I will be checking number 1 and number 3 for homework. Okay, I will be checking that on Friday when I return. Good luck.